Welcome to our exploration of innovative power solutions for data center backup power and the role of fuel cells. With the ever-growing demand of cloud computing and digital infrastructure, reliable and sustainable power solutions are more crucial than ever. The data center industry faces growing challenges that demand clean on-site power solutions to ensure reliability and sustainability. Environmental air permitting limitations restrict the use of traditional diesel generators due to emissions regulations, making it harder for operators to secure backup power approval. Meanwhile, sustainability commitments, including net zero carbon goals, push companies to phase out fossil fuel-based power and invest in renewable alternatives. Power constraints, from grid instability to local supply shortages, can jeopardize operations, particularly in regions with rapid digital growth. Finally, AI workloads are expected to impose sudden load surges, which can result in deviations in output frequency and voltage of diesel generators. In contrast, inverter-based hydrogen fuel cell solutions can offer a more responsive backup solution, delivering consistent power without the limitations of mechanical inertia. Beyond emergency power, hydrogen fuel cell systems can be integrated into data center power architectures, including electrical compatibility, dynamic response to AI-induced load fluctuations, offering additional potential for grid support and microgrid applications. However, key challenges, including hydrogen production scalability, infrastructure costs, and regulatory hurdles, must be addressed to unlock their full potential. By leveraging hydrogen fuel cells, the data center industry can move towards sustainable, reliable, and future-proof power solutions in an era of growing energy demand. Ballard Power Systems has been at the forefront of integrating fuel cells into critical infrastructure. Their fuel cell technology, used by industry leaders like Microsoft and Caterpillar, highlight their commitment to innovation and sustainability. A notable project is the deployment of a 1.5 megawatt fuel cell platform at a Microsoft data center, demonstrating increased resilience and reduced carbon emissions over a simulated 48-hour outage. One of the most groundbreaking projects is the first market-ready product developed in the partnership between Ballard and Verdive, a pioneering zero-emission backup power system designed to replace traditional diesel generators in data centers. The development journey involved several phases, including system integration, performance testing, and validation across global locations. This comprehensive process ensured that Verdive's Power Module H2, powered by Ballard, meets the highest standards of reliability and performance. The Power Module H2 integrates two of Ballard's 200 kilowatt FC-Wave fuel cells, offering a scalable solution from 200 kilowatt to multiple megawatts. This flexibility makes it suitable for new builds and retrofits, providing data centers with a robust, zero-emission backup power source. The system's architecture includes advanced cooling subsystems, power conditioning equipment, and hydrogen storage, all managed by Verdive's sophisticated energy management controller. The result is a ready-to-deploy solution that supports tier-based redundancy models, ensuring resilience and sustainability for data center operations. The Power Module H2 exemplifies a market-ready product that meets the demands of modern data centers while aligning with environmental goals. To sum up, PEM fuel cells represent a technically robust, highly scalable, and low-emission alternative to traditional diesel generators for backup power in data centers. They offer rapid startup times, strong compatibility with grid integration, and reliable performance under variable loads. Their seamless integration with UPS systems, microgrids, and AI-driven power demands makes them particularly well-suited for next-generation, high-performance digital infrastructure, especially in areas constrained by permitting issues or grid capacity limits. Beyond their core role in backup power, PM fuel cells deliver added value by supporting grid services such as frequency regulation, peak load management, and demand charge reduction. This helps data centers not only cut energy costs, but also meet sustainability targets. Their potential contribution to 24/7 renewable energy matching further supports the shift toward fully decarbonized computing environments. When used as multifunctional assets, they can improve total cost of ownership, thanks in part to their low maintenance needs and modular scalable design, an ideal match for today's distributed data center models. That said, broader adoption depends on overcoming key hurdles. the availability and cost of hydrogen, regulatory and permitting barriers, infrastructure demands, and initial capital investment. Looking ahead, advances in fuel cell technology, reductions in hydrogen production costs, and supportive policy frameworks will be crucial in making fuel cells a mainstream solution for sustainable data center power. As industry shifts toward net zero objectives, PM fuel cell solutions present a resilient and adaptable pathway for data centers seeking clean, scalable, and grid-interactive backup systems. Proven projects like those realized by Ballard with Microsoft or Verdive showcase the reliability and effectiveness of fuel cells. Thank you for joining us in exploring the potential of fuel cells in data center backup power solutions. For more details, stay tuned with Powered by Ballard and get more insights on sustainable technology advancements.